To solve radical equations, begin by isolating the square root expression, which is already done in this case. Once it's isolated on one side, square both sides to eliminate the square root, resulting in 3x minus 2 on the left. Expanding the square of the binomial gives x squared minus 8x plus 16. Rearrange the equation into standard quadratic form by moving all terms to one side. We want the leading term x squared to be positive, so subtract 3x and add 2 to both sides. This sets the equation equal to 0. The quadratic expression can then be factored into x minus 9, x minus 2. Using the zero property, we find two potential solutions, x equals 9 and x equals 2. However, it's necessary to check for extraneous solutions by substituting both values back into the original equation. Substituting 9 simplifies to the square root of 25 equals 5, which is true. Substituting 2 for x, however, simplifies the equation to the square root of 4 equals negative 2, which is false since the square root cannot be negative. Therefore, the only valid solution is x equals 9. Extraneous solutions happen when we square both sides of an equation because squaring makes negative and positive values look the same. This can create solutions that don't actually work in the original equation, so it's important to check all solutions by substituting them back in. Next, the square root of x plus 9 minus the square root of 2x equals 3. To solve this equation, start by isolating one of the square root terms by moving the negative square root of 2x to the right side, resulting in the square root of x plus 9 equals positive square root of 2x plus 3. Next, square both sides to eliminate the square root on the left side, giving us x plus 9. Let's square the right side using the square of a binomial formula. The first term squared equals 2x. The middle term is both these terms multiplied by 2. And 3 squared equals 9. Both sides have 9, which can be cancelled out. Isolate the square root by moving 2x to the left. X minus 2x equals negative x. Square both sides again to eliminate the square root, which gives us x squared, since negative squared becomes positive. On the right, squaring 6 gives us 36, and squaring the square root eliminates the square root. This results in 72x. Move 72x to the left, making it negative. Factor out x. Using the zero property, x equals 0 and x equals 72. Check for extraneous solutions by substituting 0 for x. Simplifying, we get the square root of 9 minus the square root of 0 equals 3, which is true. Substituting 72 for x and simplifying gives us the square root of 81 minus the square root of 144. Simplifying further, we get 9 minus 12, which does not equal 3 because it would give us negative 3. Therefore, the only valid solution is x equals 0. This equation contains a fractional exponent. We can eliminate it by raising both sides to the power of the reciprocal 2/3. Using the rules of exponents, multiply the two fractions, which cancel out each other, giving us x plus 18. Similarly, the 3's cancel out, leaving us with x minus 2 quantity squared. Expand the square of a binomial on the right side to x squared minus 4x plus 4. Rearrange the equation by bringing all terms to one side, resulting in x squared minus 5x minus 14 equals 0. The quadratic expression can be factored into x plus 2 times x minus 7, giving two potential solutions, negative 2 and 7. Let's check for extraneous solutions. Substituting negative 2 for x and simplifying the equation gives us 16 to the power of 3 halves equals negative 4 cubed. The exponent 3 halves means take the square root and then cube the result. The square root of 16 is 4, and 4 cubed is 64. Negative 4 cubed is negative 64. Remember, an odd exponent keeps a negative sign. This gives us a false statement. How about 7? Simplifying, we get 25 to the power of 3 halves equals 125. Therefore, 7 is the only solution.